Hello viewers, in today's class we are going to discuss yet another important and very conceptual problem from limits and continuity, right? So here once again we'll solve a very important problem from continuity of a function, right? So here we have a problem which goes like this: examine the continuity of the function, and the function is given as greatest integer of x plus greatest integer of minus x at x is equal to 1, right? So here the function f is given to be the sum of two functions involving the greatest integer function, right? And here the point of consideration is x is equal to 1, right? So here to examine the continuity of the function, let us first take the definition of continuity of a function, right? So here if we have a function, say y is equal to f of x, and it is defined in some domain, then this function is said to be continuous at some point a if the right hand limit and the left hand limit both exist and they are equal, right? And further, the value of the function, that is f of x at x is equal to a, must coincide with the value of the right hand limit and the left hand limit, right? So this is the condition for continuity of a function, right? So here what we will do, we'll first find out the right hand limit, then left hand limit, and then f of a, and here a is given to be 1, right? And we'll see whether this condition is satisfied or not by this function, right? So let us start. So let us first find out the right hand limit, right? So the right hand limit, the notation for right hand limit is limit x tends to a plus, and here we have f of x, right? So this is the general notation, and this positive sign shows that we are approaching towards x, that is a, from the right of x is equal to a, right? So here we have the point a is equal to 1, and here we'll take 2 points in the neighborhood of a is equal to 1. This point is 1 minus 1 plus h, and this point is 1 minus h, right? So now this can be written as limit x tends to 1 plus, and here we have f of x, right? So now what we will do, we'll take x is equal to 1 plus h, where h is a positive quantity and it is a very small quantity, right? So when x tends to 1, then obviously h tends to 0, right? So now we can replace here x by 1 plus h. So now the right hand limit can be written as the limit h tends to 0, and we have f of x, and x is 1 plus h, right? So now we can write limit h tends to 0, and f of 1 plus h can be obtained by replacing x by 1 plus h in this function, right? So now we have here greatest integer of 1 plus h, and then we have minus, and here we have 1 plus h, right? So now here this is a very important step, right? So here we cannot directly substitute h is equal to 0, right? So what we will do, we'll find out the value of greatest integer of 1 plus h and greatest integer of minus of 1 plus h, right? Now see, 1 plus h, because h is a positive quantity, so 1 plus h must be greater than 1, but it is less than 2, right? So 1 plus h is slightly greater than 1, but it is less than 2. So by definition of greatest integer function, the greatest integer of 1 plus h must be equal to 1, right? Now let us take this quantity. right? So here inside the greatest integer function symbol or the brackets, we have a minus of 1 plus h, right? Now see, minus of 1 plus h can be written as minus 1 minus h, right? So now see, here we have say 0, and here we have minus 1, and here we have minus 2, right? And now let us concentrate on this quantity, that is minus 1 minus h, right? Now see, h is a positive quantity, that is h is greater than 0. So minus 1 minus h, or negative of 1 plus h, that is it must lie towards the left of minus 1, right? So minus 1 minus h must lie somewhere here, right? That is very close to minus 1, but towards the left of minus 1, right? So it suggests that minus 1 minus h must be greater than minus 2, but it is less than minus 1, right? So now from the definition of greatest integer function, the greatest integer of minus 1 minus h must be equal to minus 2, right? Because minus 1 minus h, it lies towards the left of minus 1, but it is very close to minus 1. It means minus 1 minus h lies between minus 2 and minus 1. So the greatest integer of minus 1 minus h is minus 2, right? So now here we have limit h tends to 0. Greatest integer of 1 plus h is 1. And here we have greatest integer of negative of 1 plus h, that is minus 2, right? So now we have here, we can omit this notation for limits, because here this quantity is independent of h. So we have 1 minus 2, that is minus 1, right? So the right hand limit is equal to minus 1. Now let us find out the left hand limit. So the notation for left hand limit is limit x tends to 1 minus f of x, right? And now here we'll take x is equal to 1 minus h, right? Where h is a positive quantity. So now when x tends to 1, then h tends to 0, right? So now left hand limit can be written as limit h tends to 0, and here we have f of x, and x is replaced by 1 minus h, right? So now f of 1 minus h can be obtained by replacing x by 1 minus h in the given function, right? So we have greatest integer of 1 minus h, and here we have greatest integer of negative of 1 minus h, right? Now here again we cannot find out the limit by directly substituting h is equal to 0, right? So what we will do, we'll write it as limit h tends to 0, greatest integer of 1 minus h, and here we can now write this term as minus 1 plus h, right? So now here we cannot directly substitute h is equal to 0, right? So for this, what we will do, we'll find out the value of greatest integer of 1 minus h and greatest integer of minus 1 plus h, right? So now let us first consider greatest integer of 1 minus h, right? Since h is a positive quantity, so 1 minus h is less than 1, right? But 1 minus h is greater than 0. So by definition of greatest integer function, the greatest integer of 1 minus h must be equal to 0, right? Because 1 minus h, it lies between 0 and 1, right? Now let us consider greatest integer of minus 1 plus h. Now see, we know that h lies between 0 and 1, right? And now what we will do, we'll add -1 throughout this inequality. So what we will get, here we have -1, here we have -1 plus h, and here we have -1 plus 1. So we have -1, this is -1 plus h, and this is 0, right? So here what we have done, h lies between 0 and 1, so we have added a -1 throughout this inequality to get this one. Now from here we see that -1 plus h, it lies between -1 and 0. So the greatest integer of -1 plus h must be equal to -1, right? So now we can write limit h tends to 0 and greatest integer of 1 minus h is 0, and here greatest integer of -1 plus h is -1, right? And now we can omit this sign, that is symbol for limits, and we have 0 minus 1, that is -1, right? So the left hand limit of this function at x is equal to 1 is -1. So now viewers, we have seen that the right hand limit is equal to -1 and the left hand limit is equal to -1, right? And both the limits are equal. So it implies that the limit of this function when x tends to 1, it exists, right? And the value of the limit is -1 because right hand limit and left hand limit, both the limits are finite and equal. Now we have to find the value of the function at this point a is equal to 1. Right? So now f of 1 can be written as greatest integer of 1 plus greatest integer of -1, right? And the greatest integer of 1 is 1 and greatest integer of -1 is -1, because we know that the greatest integer of any integer is the integer itself, right? So now this is 1 minus 1, that is equal to 0, right? So viewers, the value of the function at x is equal to 1 or a is equal to 1 is equal to 0, and this is 0. So the right hand limit is equal to left hand limit, but these two quantities are not equal to the value of the function at a is equal to 1. So now we can write that the limit x tends to 1, f of x is not equal to f of 1, right? And we can now say that this function is not continuous at a is equal to 1, because the limit of the function is not equal to the value of the function at the given point.